Area of regular polygons. Area of regular polygons hasn't been on the SOL for the last couple years. So if you have a friend who took geometry last year and they said, I didn't learn this, well, they're right, they didn't. Honors used to learn it, but regular didn't have to learn it for a couple of years. It's not hard. It does have several steps, and you know I'm excited. I get to integrate some trig. So our essential question, how do I find the area of regular polygons? No good geometry lesson starts off without vocabulary, and you know I'm going to enjoy this one, so it's definitely going to have vocabulary. We're going to start with the word apothem. The apothem is the distance from the center to the side of any polygon. It has to be perpendicular, and we use lowercase a for it. The radius of a polygon goes from the center of the polygon to the vertex. We use a lowercase r for it. Notice between the apothem and the radius, we're forming a little right triangle. Okay, so the easy problems are if you're given an equilateral triangle and you're given the side length of that equilateral triangle. So if we know the side, then area equals 1/4 side squared square root 3. And we leave our answer with the square root of 3 in it because that's exact. For everything else, we have to use the area of a regular polygon formula. And I'm going to do my best to sketch a hexagon here because it's the regular polygon I draw the best. And I'm going to draw in my apothem, my radius. This is, I always call this x. And x is 1/2 of a side. So for a regular polygon, area equals 1/2 the apothem times the perimeter. So we need the side lengths to find the perimeter, and we're going to need the apothem, and that's where the trig comes in. So what are the steps for doing this? Well, I'm going to draw in my radius. This is going to be x. This is my apothem. This is r. My side is 2x. You create a right triangle. By drawing in the radius and apothem, which I did. I also labeled everything while I was doing it. I always pull this right triangle out so that I can see it more clearly. In this case, my apothem is 5, and that's all I know so far. We have to find the measure of the angle right here, formed between the radius and the apothem. Okay, so if I draw in a second radius, I now have a central angle. I know I can find the measure of my central angle by doing 360 divided by n. So there's 1, 2, 3, 4, 5, 6 sides. 360 divided by 6, I have a 60-degree central angle. For my triangle, I need to do half the central angle. So 60 divided by 2, I have a 30-degree angle here. 30 degrees. Okay, now you know that's got me excited because that means I've got a 30, 60, 90, right? And I'm going to get to do some special right triangle relationships for this particular example. If I didn't have a 30, 60, 90 or a 45, 45, 90, I would be using trig to solve for my missing side lengths. Sine, cosine, and tangent. So, TOA. But this example, I've got a 30, 60, 90, right? So I know that if this is x, 5 is x square root 3, and this will be 2x. So let's see. X equals 5 square root 3 over 3. And this side will be 10 square root 3 over 3. Okay. I need to find my perimeter. And in this case, it's 6 times the sides because I have a hexagon. My side, if I come back up here to my diagram, is 2 times x. So x is 5 square root 3 over 3. 10 square root 3 over 3 will be my side length. So 6 times 10 square root 3 over 3, and that gives me 20 square root 3. And now it's time to substitute into our formula and solve. So our formula for a regular polygon that is not an equilateral triangle is 1/2 apothem times perimeter. That's going to be 1/2 times 5 times 20 square root 3. And that gives me 50 square root 3. Do I have units up here? Inches. Inches squared. So there are a bunch of steps, but it's not that hard. Let's give another problem a shot. Okay, now this is an equilateral triangle, but they gave me the apothem. They didn't give me a side length. So I have some choices. I can use the 1/2 apothem times perimeter. I can figure out what my side length is going to be and use the 1/4 side squared square root 3. Since they gave me the apothem, I am going to go with 1/2 apothem times perimeter. So this is going to be 1/2 18 times, I've got no idea at this point. I need to draw in my radius, and I need to figure out, that's going to give me this beautiful right triangle. I need to figure out this central angle. So for my central angle, 360 divided by 3 sides is 120. Cut that in half for the measure of your angle in your triangle. It's another 30, 60, 90. But this time, right, they gave me the short side. So double 18, my radius is 36, and my long side here is going to be 18 square root 3. My side is 2x, so this side is 36 square root 3. My perimeter is 3 times 36 square root 3. That's 108 square root 3, which I'm going to substitute in. What do we get? We get 972 times the square root of 3 millimeters squared. Let's do another one. What did they give me? A pentagon this time. They gave me the apothem. So my apothem is 10. There's my radius. There's x. My side is 2x. Let's go ahead and find the central angle. The central angle would be 360 divided by 5. That's what? 72? So if I cut that in half, I get 36. Let's take out this triangle. 36 for my angle, 10 for my apothem, x, r, oh boy. Okay, I want area equals half the apothem times the perimeter. I know the apothem is 10. I've got to find perimeter, which means I have to find x. Trigonometry. SOHCAHTOA. Opposite, adjacent, hypotenuse. So if I use tangent, 36 equals x over 10. X will equal 10 times tangent 36. Don't put that in your calculator. Okay, let's go back up to our original diagram, and a side is double x. So my side length is 20 tangent 36 degrees. Now my perimeter is 5 times the number of sides. So that's 5 times 20 tangent 36 degrees. 5 times 20 is 100. Now I'm going to put it in my calculator. You never want to round until the very, very, very last step. Okay, make sure your calculator is in degree mode. And mine was not. There we go. So 0.5 times 10 times 100 tangent 36. And I get 363.27 inches squared. Isn't it awesome how we got to integrate a little trig into this? Yes, Miss Austin, it's fabulous and it's wonderful and we're enjoying ourselves. Go ahead and pause the video and try this one on your own. Okay, I'm going to spend a little more time talking you through this one. I have an octagon, so I need to use my 1/2 apothem times perimeter formula. I didn't know the apothem, I didn't know the perimeter. Okay, I did, however, label my diagram, going ahead and putting in the apothem, the radius, and cutting the side length of 14 in half for 7, so that then when I pulled out my triangle, I at least had one side length on my triangle. At that point, I said, okay, what's my central angle? So 360 divided by 8 is 45 degrees. Cut that in half for the triangle, and I have 22.5 degrees. I used trig to find the apothem, and I did not put that in my calculator. Okay, I substituted the entire expression back up into the formula. Then I found my perimeter, 8 times 14, and substituted that. And then I used parentheses on my calculator to put that whole expression in at one time to end up with 946.37 meters squared. Okay, I want you to try this one on your own, and it's the very first formula. We know the side of an equilateral triangle, so we're going to use the area of an equilateral triangle formula. Pause your video. These are the best when you know the side length. It's just a matter of substituting, keeping the square root of 3 in your answer, and you're done. Okay, in your summary, be sure you write the steps for me for solving the formula 1/2 apothem times perimeter.